Cool.
No problem.
Bye, Nancy.
Thank you, Nancy.
Thank you.
You are live.
We did it. We're live.
Sounds like there's a whole police chase happening outside my window right now.
Somebody
Don't
was
hear it,
playing the trumpet outside, and like I live in the middle of a Canadian rainforest.
Isn't that one of your family members? Is the only answer?
I guess so. Like
Did a child take up the trumpet?
Easily a kilometer away from my nearest neighbor, and yet I heard the sound of somebody playing the trumpet just a few minutes ago. Very surreal. Yeah, my wife was just remarking. She's like, I've never lived in a place where there are no lights from any of our neighbors. There are no sounds from any of our neighbors. It's dark and quiet here, which is great.
Yeah, it's a little different than Dallas.
Yeah. Yeah. Ugh. Even a little different from the house that we had before. So, yeah. It's it definitely takes some getting used to. A little eerie.
So I've noticed, Fraser, that you no longer say hello to people at the start of in this time. Did we decide we no longer are friendly with people? Too many streams to judge now? Is that the problem? It's like, is it the Twitch people or the YouTube people? Or That was a well-worn pastime.
Is it what people preferred?
Oh, I do not know on that front.
Hello to Alex Desplan, Ben Kalo, Dystopian Farmer, Ian Farquharon, Nancy Graziano, Scott Bragdon, WI Block, and Zapfan. But maybe it's a short list now, and so then I feel bad. Hello to Larry King, Roger Haskins, Kim Barron.
Well, people are just spread out across more platforms now than they used to be.
Yeah, I can't say. You know what? Actually, you know what it is? It's because we're live on Twitch as well, and I don't say hello to the Twitch people. It's not like they're dead to me. I'm not saying that. They are.
Tip and Fraser will read your name.
They're as meaningful to me as the people on YouTube. I just don't have their names in front of me. That's just and am I too lazy to go get them? Maybe. No. The reason is because I am on Starlink, and I'm already trying to upload my stream and to then download 2 separate video streams and chat would decrease the quality of my output.
You think Elon's gonna exempt Twitter traffic from Starlink going forward? Yeah, just Twitter from anywhere on Earth at no charge.
Yeah. Pamela, are you gonna pay for your blue link? I don't know if Pamela can hear it. Nancy, are you gonna pay for your blue link?
Absolutely not.
Absolutely not. No, I won't.
Not even at $8 a month.
I mean, Stephen King really did negotiate in my honor on that one. No. I mean, fundamentally, it misses the point of the blue check mark. Right? The blue check mark is a way to stop people from impersonating me on the internet. The blue check mark is a way that people can know that I'm actually the journalist that I say I am. And so I think that everybody should get blue check marks in some way that they verify that they are who they say they are. That's what it's for, is that and then you can, if you could give everybody these, then you could trust the voices and truly drown out the trolls. So
did you see the tweet by Katie Mack where she was talking about the reason for the blue check mark, and then somebody replied and tried to knock her down, and then right underneath was a person who had just spoofed the person who was trying to knock him down. He had the same picture and his spoof name. It was golden.
That's awesome. Yeah. So
and for so little revenue.
Yeah, and so I think that's it. It's astonishing to watch one man destroy a platform this quickly.
Couldn't have happened to a nicer company.
See, yeah, that's the thing, right? Like, whatever happens, it is all upside, in my opinion. Like, on the one hand, Twitter, this hive of scum and villainy, craters, and then you no longer have this hate patrol that is constantly ruining people's lives and their brains, or Musk figures it out and it's made better. And either outcome, in my opinion, is perfectly fine.
Yeah, but where will be the new place to go doom scrolling?
Well, I think you can do that on most of the internet now at this point.
Yeah, I don't think there is.
Exactly.
Like, I think the age of the social media is almost over. Right? Because TikTok
chisel that into stone. Facebook will go bankrupt next year.
Well, I mean, they're switching to Meta, which
I wouldn't even complain.
Yeah, exactly. It'd be fine too. Like TikTok, right? TikTok is this genetically engineered monster. This only job is to entertain you. It has thrown off all vestiges of trying to connect you, trying to find out who your friends are. It doesn't care. It just wants to hook you up to the dopamine and just feed your happiness until you pass.
The best thing about TikTok is you have to install the app, which has successfully kept me from ever having seen a TikTok. At least on Facebook or on Twitter, you can still get the little web view, which is lets you click through. But having to go to the app store and get the app is one step too far for me.
No, it says no data, Pamela. Well, maybe it's back. Let me know. It's back now. It says error, you need to change the resolution, which is fine. But let me know if we've stopped. I guess. Let me know if you can still see us. Okay. All right. I think it just dropped for a second there. Okay. We're all right. How are you doing, Pamela? Can we start? Are you still... Wait. Okay.
There's so many chats.
Got it. Okay. All right. I was killing time unnecessarily. So let's get started. All right. Well, I hope. Are you not entertained? All right. Hello and welcome to the Weekly Space Hangout for Wednesday, November 2nd, 2022. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about Mars. Falcon Heavy launching, radio telescope on the far side of the moon, meteorite impact on Mars, the inflatable decelerator system on Mars, and more. Joining me this week, we've got Morgan Redberg. Dr. Captain Morgan Redberg.
Hey, Fraser. It's been a month or so since I've been on last. Has SLS launched yet?
Somebody made the funniest joke at me today where I had sent a recent video that SLS is going to be launching, and someone had just asked me what is your source for this? It's gonna launch. It's gonna launch. Yeah, it has not launched, but Falcon Heavy, as we are about to learn, has launched. So heavy rockets can leave Earth.
Hashtag next month.
Fat flat earthers. All right. We've got Nancy Atkinson. Hey, Nancy.
Hi.
And you have congratulations on 6,000 articles for Universe Today.
Thank you.
Oh my gosh.
That's awesome.
Yeah, it's amazing. Yeah, it's it's second place.
Right.
But
exactly.
I've got 6,200. So I think, and I haven't written very many articles, so I think I'm a goner.
I think she gets to become publisher in 200 articles.
I believe that's how the rules work.
Wow. It's like Highlander.
Yeah, the only one. Yeah. Well,
I don't think so.
Now, Nancy, you conducted our interview mostly today, which was really exciting. So we're going to be going. We don't have a guest, but we have an interview. So we're going to play the interview at a random time of my choosing. and that will wrap up our part of the episode and then go into that. And it was great. It was really refreshing because normally I'm the one that does the interviews. Nancy did the interview, except her internet died. And so I had to jump in and ask one question, and then it goes back to Nancy for the rest of the interview. So enjoy that. And it was a great interview, and Nancy did terrific. So
you always need a little excitement.
Yeah, exactly. And then we've got the new guy, Darren Dixon. Welcome to the Weekly Space Hangout.
Hey, happy to be here.
So tell us about yourself.
Yeah, so I am a former Mars rover operator now. Last time I was on the show as a guest shortly after Perseverance landed, back when I was an operator on Mastcam Z. And prior to that, I operated Mastcam on Curiosity. But I've since left the rover operations world, back in my hometown of Milwaukee, Wisconsin, starting on my PhD, going through the rigors of fatherhood. I have a child that will be 1 on Saturday now. And yeah, still studying Mars and learning how small humans work.
They're more complicated than rovers.
Much more complicated.
Yeah, exactly. And where are you going? Like, how are you continuing your education? What are you getting your PhD in?
Geology. So I started off as a geologist, and from there pivoted into rover operations, and now I'm going back into the geology side of things and still exploring Mars, interested in Jezero Crater, and I'm excited to be back looking at rocks instead of ones and zeros. Both are great, though.
It's got to be peculiar that you're experiencing geology through a robot that is hundreds of millions of kilometers away.
Yeah.
As opposed to just like walking out and picking up a rock and going.
Exactly, right? I just the dream is to take a rock hammer to Mars. Just
Yeah.
That's the goal. To be out there splitting rocks on Mars.
Where would you go? What would be like the top, your number one place if you could like go with a rock hammer and air on Mars?
Number one place, probably Gale Crater. We've seen so much just diversity of terrain and geologic features at Gale Crater that I think like it would just be a spectacular hike through Mars.
Yeah.
Yeah.
I mean, isn't that where they like even just now, like where Curiosity is, like they've reached one of their great dreams is to be at the edge of this ancient sea.
Yeah, and their Curiosity is still very active in Gale Crater, despite those wheels looking like Swiss cheese. And they're finally up in that sulfate-rich, salty unit where, years ago people were just kind of frothing at the mouth at this stuff in CRISM data from orbit. And it's spectacular that they're finally
hiking trail on Mars is a dynamite science book idea.
Yeah, right.
Somebody take that as a pop sci book. That is just that's a gimme.
Yeah, that's a good idea. I like that. Yeah, I love it. Well, Darren, again, thank you so much for agreeing to join us. Hopefully, you will get out of this journey as much as you provide to us. But pleasure to have you on board.
Glad to be here. Thank you.
All right. Before we get into this week's news, I want to give a huge shout out to our good friends of the Weekly Space Hangout crew. They're our friends, our fans, executive producers. You can join this amazing community. Go to wshcrew.space and they will hook you up with all of the details. All right, let's get into the news this week. First, Morgan, let's talk about this meteorite impact on Mars.
Oh, this is so cool. I think last time I was on here, I was talking about some collabs between MRO, the Mars Reconnaissance Orbiter, and InSight. Mars Reconnaissance Orbiter, of course, orbiting Mars with a super high resolution camera capable of capturing 50 centimeters per pixel on the surface. InSight, lander on the surface, which has a seismometer. It made an attempt to drill down. That didn't go so great. Make some temperature measurements, a weather station. But the seismometer is sort of the groundbreaking piece. And so it's been sitting on Mars now for a few years, listening for Mars quakes, many of which seem to be the result of impacts that are happening on the surface. And it's picked up a variety of different impacts, but they've all been pretty far away. And so it picks these up by feeling the seismic waves that leave the surface, basically travel down to the core, bounce off the core, and back around the planet until they reach InSight. Just this past year, actually on Christmas Eve in 2021, something really cool happened, which was that there was an impact that was not only close enough, really, really close to InSight, but it also happened to be the biggest impact we've recorded on Mars, basically since we've been sending spacecraft there. So this impact, you can see a picture of it there from Mars Reconnaissance Orbiter, has a diameter of about 130 meters. And so that's a pretty sizable crater on Mars. And it's a pretty good rule of thumb that the impactor itself is usually about 1/10 the size of the hole that it makes. So we're talking about a rock that's, house-sized, basically smacking into the surface. And because MRO took pictures on the day before and the day after, we know basically exactly when this happened. And it happened to be the same time that there was this seismic spike picked up by InSight. And what's cool is because this impact was so large and so close, for the first time in its mission, InSight picked up direct seismic waves. So these are seismic waves that basically traveled through the surface and reached the seismometer and the lander, rather than bouncing off of the core and bouncing back up. And that basically allows us to use that wave to probe the material between the impact and the lander itself. And what we found was that the material in the impact area was actually quite a bit denser than the material on the surface at the crust, basically, where InSight actually is. And so that tells us that there's pretty significant crustal variation on Mars, at least in terms of its density and probably its composition, which has really big impacts for us as we try to understand the geologic history of Mars. If we send more seismometers, they're going to pick up different things depending on the kinds of material they're sitting on. As we look at surface processes, cratering, old volcanism, etc., we need to remember that it's not just like Mars rock. Just like on Earth, there's this vast variety of rocks. And there's areas that are all one rock and areas that are all other, and then in-betweens that are kind of mixed up. So this is such a cool kind of combo between these two sources. And unfortunately, it's probably going to be about the last one we get, because NASA is estimating that within the next 2 to 3 months, InSight will shut down for good because it's been accumulating enough dust on its solar panels that it's going to run out of power and freeze to death.
And before people start suggesting ideas for how to fix InSight,
they've thought of them all.
NASA's thought of them all. They've thought of that. You know that idea you just had? They've thought of that. A tiny brush? Yes.
Windshield wiper.
Windshield wiper? Little blower? Yes, they've thought of that.
Yeah, that's the one on with your windshield wipers. I'm like, they definitely thought of that.
So this sounds like the perfect place to examine really fresh samples of Mars. Like, if the whole point with Gale Crater is that you are looking at this place that was excavated hundreds of millions, billions of years ago, but you're seeing back through the layers of Mars, this is utterly fresh. Like, there could be biological samples that were protected by the regolith that now are accessible by some kind of rover. Does this feel like it would become a very high priority to go back to?
I mean, I think anytime you see this kind of surface exposed material, it's showing you something that's been locked away. And, through remote sensing, this is basically the only way that we get to look inside of planets. A few places we can send a rover or a lander and drill down, a few centimeters to a few meters. But, this crater has excavated tens of meters down. It's thrown all that stuff out onto the surface, where we can look at it with spectrographs and cameras and things, but also where it's now available for access by the surface, whether that's an astronaut with a rock hammer going over there to whack on it, or a next generation rover or a lander or something like that.
Yeah, it's really exciting. And the fact that, like, it was far away from InSight, and yet InSight pretty much just picked it up halfway across the planet, right?
Yeah, and if we can get more of these seismometers on the surface, we're going to be able to do amazing things. On Earth, we basically use networks of seismometers to be able to triangulate and measure the different distances between what one place heard and what another place heard, and work out these sort of three-dimensional surface structures. Because Insight has these single source, we're having to do a lot of super fancy math to try to pinpoint where the locations actually are, because most of the time we don't see the impact like we did here. And where we've been able to test it, it turns out Insight can predict within like 100 kilometers on Mars of where this is. But if we had 2 or 3, that would improve dramatically. And you could really get this 3D imaging that we've used to peer inside the Earth with earthquakes and things like that.
Yeah, that would be really impressive. All right, Nancy, Falcon Heavy.
Yeah, we finally got to see a Falcon Heavy launch. C is a bit of a stretch, though, because there was fog just enshrouding the entire Kennedy Space Center yesterday, Tuesday, November 1st. But yeah, we got to see the liftoff, kind of, and then the really exciting part was seeing the 2 boosters come back down and launch and land back at Kennedy Space Center. So that was exciting. It was a classified mission for the U.S. Space Force. So we don't know much about it, but it was multiple satellites, is what they said. And the last time that
they didn't recover the central.
No, there's not. For some reason, there's not enough fuel in that central booster part, the main booster part, for that to be able to come back down. So that kerplumped into the ocean. But otherwise,
this was the first time, right, that they had put a satellite directly in a geosynchronous orbit on a Falcon product, and I think wonder if that plays something to do is all that extra fuel being used to put it directly into this far off orbit.
Right, because back in 2019, the last time that the Falcon Heavy launched, they did a space test program mission, and that was like an experimental satellite for the Pentagon, and that one wasn't actually operational. So this is the first operational one that Falcon Heavy launched, and first a geosynchronous. So that's it's big news. The boosters coming back is just, I don't know, it's just so cool. It's just, and having the dual boosters coming back simultaneously is just awesome. I think
it's been 40 months since a Falcon Heavy has been launched. That's a long time.
Not in heavy lift rocket time.
Right, and that's
I'm
the
wondering,
thing.
is there a lack of payloads for heavy lift rockets? If so, does this call the whole question of Starship into question?
Well, kind of. I mean, yeah, they just haven't had a customer that needed the heavy lift. Now they're going to, Falcon Heavy is tagged to launch the Nancy Grace Roman telescope, also a Europa Clipper, and also maybe the Lunar Gateway habitat. So those are things coming up that would be pretty exciting for Falcon Heavy to launch.
There was an interesting article, Fraser, by Eric Berger at Ars Technica this week, asking that question, basically. Mm-hmm. And one of the answers that he sort of deduced was that the way NASA is structured sort of disincentivizes this heavy lift payload, because science groups at NASA basically work independently of the launch services folks. And so basically, the allowance hasn't been made yet to use these heavier lift reusable rockets to actually create new kinds of payloads. And so until it's there long enough that sort of NASA says, okay, the old rules are out and now we can accommodate payloads up to X amount, they're still sort of designing them under the old ways, where if you weren't a flagship mission, you basically couldn't have a lot of mass. And so even if, launching on a Falcon Heavy now is cheaper than launching on an Atlas V, 10 years ago, and you get 3 times as much mass or something, the rules basically still say, your mass allowance is pretty tightly tied to your budget, even though, Falcon Heavy and then, of course, Starship in the future are looking to kind of decouple mass and price in a way that we haven't had in the launch industry before.
And I guess that's the question, right? Is that if you do get the Starship, if the actual cost per kilogram is significantly lower, say it's even, I don't know, sub $1,000 a kilogram, at that point you can just kind of say, don't worry about the mass. Like, just build your satellite.
Right, you could make things cheaper if you didn't have to make them lighter. A crazy amount of engineering goes into exotic materials and techniques to save 10% to fit into the fairing of a rocket. If you didn't have to worry about that, you could be launching basically Earth-grade equipment a lot cheaper than what you're engineering to make fit in like some tiny little power and mass envelope.
And I wonder, is it also possible that SpaceX itself has kind of moved on mentally from the Falcon Heavy, and so they're just not pushing it anymore, do you think?
Well, I think the majority of the payloads is the only require the liftability of the Falcon 9. So, don't outkick your coverage by, having a bigger rocket than you need.
Well, and they've made Falcon 9 so much more powerful since the Falcon Heavy program sort of was conceptualized that, it's, 50% more powerful now than early Falcon 9 was. So I suspect a lot of loads that they intended or envisioned going on Falcon Heavy, 10 years ago, have actually been picked up at the upper end of like an expendable Falcon 9. And if you're going to lose the center core a lot of the time anywhere on Falcon Heavy, why not save the money and just, burn up a Falcon 9?
Yeah, that's a really good point.
Yeah,
Morgan.
I mean, it feels like, they're pretty urgent about switching over to Starship, but they have kind of engineered the Falcon 9 so well at this point and so reusable that it is gobbling up pretty much the entire launch market at this point. Awesome. All right, Darren, you've seen them all go. Tell us about an inflatable heat shield.
Yeah, so Lofted, NASA's low Earth orbit flight test of an inflatable decelerator. This is an inflatable aeroshell heat shield. So the aeroshell is made of two parts. There's the heat shield. That's a flat half kind of on the bottom of a spacecraft or some sort of cargo entering a planetary atmosphere. And then the back shell is a large painted cone-shaped half on the other side, which contains parachutes and cameras and other equipment. And NASA is soon, hopefully, engaging in this test to test an inflatable aeroshell, which is a big difference from these rigid metal aeroshells that we're used to. And one big advantage of that is these rigid aeroshells can be constrained by the size of the rocket that they are riding on, and that can have an impact on the size of the payload that you can actually land on a surface. These inflatable aeroshells also bring the benefit that a huge benefit on Mars. That, as we know, Mars has a very, very thin atmosphere compared to Earth, and so while we use atmospheric drag to slow down things on entry, there's not a ton of drag entering Mars with that thin atmosphere. And when you're dropping something down as heavy as a Curiosity or Perseverance class rover, you're not getting a whole lot of drag to decelerate that thing as you get towards the surface. And you have to come up with, really crazy and creative and incredible ideas, such as the sky crane, which is fantastic. But I think for a lot of Mars people, myself included, we know that the sky crane has limitations to the maximum amount of weight it can handle, and it's a little horrifying. Before I started working on Mars rovers, I remember hearing about the 7 minutes of terror on Curiosity. I'm like, wow, that's wild. And then to live it on Perseverance is an entirely different experience. I'm sitting there like, the strength of that sky crane is my job security right now. So the idea of inflatable aeroshells helping with deceleration and increasing that drag dramatically higher in the upper atmosphere, I think is incredible. And so
if Perseverance and Curiosity are the limit of the existing backshell, parachute, sky crane landing system, what could an inflatable landing system like this provide in terms of mass that you could get to the surface of, say, Mars?
Yeah, and I wish I had exact numbers on the mass, but I think one of the benefits of this is scalability. With this inflatable aeroshell, you can really increase this diameter as needed to suit your payload. And the aeroshell that they're going to be testing here, the launch got delayed. It's now, I think, no earlier than November 9th. So hopefully we'll hear about how that goes soon. It's launching on an Atlas V, and it's packed into a bag that is 2.3 meters high and 1.3 meters wide. And it's going to expand out to about a 6-meter diameter. So there's a pretty large aeroshell that can pack into a pretty small space. I think you get the benefit of that scalability, that as you do increase mass, you can potentially increase the diameter of this thing as well to kind of, keep up that drag proportionally.
And Nancy, you've done a lot of reporting on this problem. Have you looked into this system?
Yeah, there were several years ago. It had to be probably at least 10 years. They tried another one, and I don't think it worked all that great. It was a test in Earth orbit. And I mean, we've talked to like Rob Manning from the Mars rovers team, and he just has kind of a laundry list of all the issues that we have with landing large payloads on Mars, just because of the thin atmosphere. It's thinner than Earth, but it's thicker than the moon. So we can't land like we do with parachutes on Earth, and we can't land just with thrusters as we do on the moon. So it's got to be a combination of systems. And I'm really excited for the inflatable decelerator. I think it's a great concept. That was something that Rob Manning told me about back in probably 2005 or 6, that he thought was the best hope on the horizon for getting large payloads to Mars, to the surface of Mars.
I had heard 3 tons. If I remember vaguely, it's 3 tons is to Curiosity and Perseverance are 1 ton. This gives you like triple. And that is this is their best idea, that the most possible mass. And when you think about this compared to SpaceX is planning to bring in Starship and be potentially landing 100 tons propulsively on the surface of Mars.
Yeah, and the other thing that
is really stretching to figure out how to bring 3 tons down. It's quite an adventure.
Yeah, the other thing that Rob said was that nobody really talks about this issue, that we don't have the ability to land on Mars with large, human-sized payloads. And, I've mentioned it to people, who are SpaceX fans or Mars One fans, and they just shoot me down saying, "Oh, we've got that's easy to figure out," and it's not. It's really, really difficult.
Yeah.
You can kind of see the pieces here coming together, though, right? We were just talking about what do we do with these increasingly heavy lift rockets? Mm-hmm. Well, we can launch more stuff. Well, how do we get that more stuff down to the surface of the place we want to be? Well, now we have a thing to slow it down, even if it weighs a lot more. And so it's like neither of those on its own is the solution to a problem, but together they're the start of being able to send, bigger rovers or human payloads, that kind of thing.
Yeah. There was a story last week that Carolyn brought up, this idea of a one that has crumple zones. I don't know if you guys have seen this story, but essentially the lander is designed to crunch as it hits the surface. And so instead of having any landing system at all, it has a parachute, and then just as it hits the surface of Mars, it has these crumple zones that keep the scientific instruments safe, but, can handle whatever the G-force is. And it feels like with this inflatable lander system, you've got this nice balance, because then you have an even bigger size, and maybe you put one of these collapsible crash zone landing systems on top of it, and you sort of, you have a new way to get very heavy payloads on Mars relatively safely. I don't know though. Darian, when you were there watching as Perseverance was coming down, and you had the 7 minutes of terror, it's just different terror having your giant inflatable. How would you feel?
It's true. Yeah, it might still be a little bit of terror knowing that instead of a crane, it's a balloon essentially. But the idea,
kind of like a throwback to the old Mars exploration rovers.
Yeah, the bounce house.
Right, that was awesome. Yeah. Yeah, I love all of these just crazy ideas. Like, it shows you how difficult Mars is, that you've got all of these really creative ideas to try to land some system, some payload on Mars. So now you said that it's going to be launching on an Atlas. Do we know when they're doing this test?
No earlier than November 9th is the latest update. It's been delayed.
Okay, but like in a couple of weeks.
Yep. Soon.
Wow.
So they're going to be dropping from low Earth orbit. It's going up on an Atlas V, along with some sort of polar survey satellite. And then once that exits, they're going to chart a course for a reentry maneuver. And about 75 minutes into the operation, they're going to release Lofted, and it's going to come down, land near Hawaii after releasing parachutes. And there's just a whole array of sensors on this thing. Hundreds of heat sensors, cameras, radiation sensors. So they're really pulling out all the stops to completely investigate how this goes.
Now, why are they testing it on Earth? Like, how is that not? I mean, that's not Mars.
I think it's just kind of, a gradual approach. There's been interest in inflatable decelerators for years now. It's not new, and there have been tests both on the ground and in the atmosphere with mixed results. And I think it's just kind of slowly up in the ante,
Yeah. And also like the high altitude of the Earth, like you can actually mimic Martian atmosphere at the right altitude. They test all
significantly high enough. Yeah.
Yeah. And they test all the Martian parachutes in that way. We actually watched the European Space Agency's parachute fail spectacularly with a recent set of tests. Which was one of the reasons why they had to delay the landing system. But very cool. Thanks, Darren.
Yeah.
All right. Let's talk about a radio telescope on the far side of the moon, Nancy.
Yeah. So, Fraser, how many articles have we written about people having ideas for having a telescope on the moon? I don't know the answer. This is just a rhetorical question a lot.
I don't think there are numbers that large.
Yes. So most of the time, people have these great ideas for doing astronomy from the moon, especially the far side of the moon, because there's so much you can do from there. But the logistics of trying to build a telescope on the moon when we've only just landed, a few things on the moon and not done any construction, it just pushes it off into, really far into the future. Well, this idea for creating a telescope and doing it robotically has been around for a while, but they've had some new kind of breakthroughs or ideas of things that they could do to make this feasible. And in fact, I talked to Greg Hallinan from Caltech. He's a radio astronomer there. And he said, basically everything would be ready to go right now, except for the lunar lander. And they could launch by 2028 because everything would basically be kind of off the shelf. So this is called FARSIDE, and that stands for the FARSIDE Array for Radio Science Investigations of the Dark Ages and Exoplanets. So that's a mouthful. Like I said, this concept has been around for a while, but they've come up with these new ideas of using rovers that have been under development by JPL for the past 20 years, called the Axel rovers. And I know that we've written several articles about them. They're these kind of two-wheeled rovers that are attached to a base system with a tether. And so they can go over really treacherous terrain, down hills or across craters or that kind of thing. So they're very versatile. And so and then the other component of it is a lunar lander, which would bring all these things to the surface. And Hallinan and his team have been talking to Blue Origin about using their Blue Moon or lander. So they've really come up with some great ideas for that as well. And so the idea is that inside of the tethers of these Axel rovers would also be the radio telescope, these dipole telescopes for doing radio astronomy, and they could be embedded in there, and the tape or the tether tape would only be just a couple of millimeters thick, which I think is absolutely amazing. And so, it's pretty exciting. Oops.
So they would it's like this lander would land on the moon, and then these little, what do you call those things? Hoverboards?
Kind of, yeah.
Would roll out, and they would lay down this 2 millimeter long thread across the surface of the moon, and that is your radio telescope. That you've got a dipole telescope that is just a series of wires, and you create this giant like crop circle pattern around your lander, and that creates a radio telescope. What could you do with a radio telescope like that on the far side of the moon?
So I don't know if you guys can see me, but my screen is blank. Anyway, I'll keep talking. You could do.
We see the shapes, spirals, petals.
Yes. So those are the concepts for what the best way to lay out your telescope is, and what they determined is that the spiral, the four kind of arm spiral is the best as far as having the best, most efficient layout for the rovers, and also the best kind of clarity for your telescope as well. So I mean, the things that they said that they could do with it is kind of almost unlimited. The things that they were most excited about is looking for magnetospheres around exoplanets and telling us more about those, because we don't really know anything about that right now. And looking back into the dark ages.
I just want to stop you on that So I want to stop you on that magnetosphere one, because it's really it's kind of cool, right? That you would use this telescope to scan the sky for the flashes of radio waves coming from the magnetospheres of exoplanets interacting with solar flares coming from their star. And so you are discovering the planet through the presence of the magnetosphere, and also discovering a protective magnetosphere around a planet. And so then you do follow-on observations to see if the thing is within the habitable zone of its star. And now you found a habitable world, or at least a world that's protected from solar flares from its star. It's incredible to be able to do that.
It's really incredible.
That's one piece.
Yeah. And the thing is, we really can't do that from Earth. So having this ability to have that kind of sensitivity to be able to detect that is something that, it's basically, I think we could only kind of do that kind of thing from the far side of the moon, because we have to get away from all of the interference from Earth, from our sun, and even, from sources within our own solar system. So yeah, it's really exciting.
And then you also mentioned being able to see right out to the beginning of the universe.
Right. Yeah. And that's something that, radio astronomers have wanted to do for a long time. And you can get back to a certain point. But yeah, this would be able to see some of the early stars and galaxies, which is kind of the holy grail for astronomy.
And so this thing, the way it's laid out, it obviously isn't pointable. So we're just scanning as the moon passes by.
Right. And he said,
my understanding is that you have. Go ahead, Nancy.
Okay. Yeah, it's just laying on the ground. So it's basically looking up and looking out into the cosmos. So you're dependent on what you're able to see at that specific point in time. But he said that it would be really, really sensitive and really, really versatile as well.
You could point it like with phasing, right? Like you do point ALMA or something, using the sort of phase of the different arms of the spiral, I would think.
Well, the thing that you get is that the moon is on an eccentric orbit from the Earth, and so it rises a little above and a little below in the Earth's orbit, and the Earth has a little bit of a wobble above and below the plane of the ecliptic, and so I think it gives you like you get like a 5-degree chunk of the sky that you can access, maybe even a little more, just orbit after orbit after orbit as you slowly build up. You imagine, as the permutations of the different orbits are coming together, you're getting these ribbons of the sky one after the other. So, like the Murchison array, the one that's in Australia, that's the precursor to the square kilometer array. Like they've figured out some pretty interesting ways to point their telescope when it's just a bunch of Christmas trees, metal Christmas trees out in the Australian outback. So, I'm sure there's some clever ways to get a little bit of a wider field of view. Yeah, I love the idea. And it's like, as you say, Nancy, we have reported on many, many ideas. And this one by far feels like just the most feasible. 1 lander, 4 rovers, they're small, they drive around, boom, you've got a telescope.
Right. Yeah, I think it's a great concept, and they've really refined to be able to use things that have been tested and used before. So except for the blue moon lander, but we'll hopefully get to test that out soon too.
Yeah. All right. So Morgan, one last story, and then we'll wrap things up.
Yeah, we learned recently about the retirement of sort of a semi-mythical figure in the realm of space sciences, and that's Ed Stone, who has been the project scientist for the Voyager mission for 50 years. Basically, since the day it launched, he has been the man leading the way, coordinating all the science teams, identifying the priorities, setting the Voyager mission, essentially. And along the way, he found time to be the director of the Jet Propulsion Laboratory. He shepherded dozens of missions into the solar system on behalf of JPL. And after 50 years at the helm of Voyager, he, I think, has well earned a rest. And so Voyager will keep going, and we know it's been in good hands for all this time.
It is amazing. Like someone is filling his shoes. The responsibility has been handed to somebody else to take over being the principal investigator of this mission of these spacecraft. Like they're still going, right?
Yeah.
50
I mean,
years.
He still gets up at scientific conferences and gives his little 7-minute slide talk like every other scientist about the newest thing he's been working on. It's like, oh, by the way, this is 48 years of magnetic field measurements from Voyager or something, and just a remarkable person who has helped deliver one of the breakthrough science endeavors of the 20th century.
Yeah, so great. Thanks, Ed. All right, so we're going to wrap up the show now, but it's not over because there is going to be a really fascinating interview that Nancy did. So you're going to want to watch that in a moment. So before we go, Morgan, what are you working on, and where can people find out more?
Yeah, I've written a couple of cool stories for the magazine of AGU, EOS. You can find those over at eos.org. You can always check out my website, morganrenberg.com.
Nancy.
I've written more articles for Universe Today and will continue to write more articles for Universe Today. So I'll just keep the ticker running. You can find me on Twitter at Nancy_A.
Right. For at least another week anyway.
Yeah.
All right. Darian.
Just getting situated in my first semester of PhD, kind of figured out my project, narrowing in on what I really want to focus on and study on Mars, and got a lot of loose threads and ideas that I'm working out with my advisor, but it's kind of what I'm working on these days.
What your thesis is going to be on.
Yep.
That's awesome. Have you thought about maybe discovering life on Mars?
I have to add that to the list. I don't have that on
Aim
there.
high.
Yeah, aim high. Yeah, exactly. Yeah, and then just see what you can do.
I hear Ed Stone's free to be on your thesis committee.
Yeah, I'll just shoot him an email.
He's got a little time on his hands now.
Well, Darian, I heard you're not busy right now.
Thank you so much for joining us this week. It was an absolute pleasure to have you on board, and I look forward to more of your space news. So I'm going to shamelessly self-promote the interview that I just did with Lee Feinberg on my YouTube channel. I feel like it's one of the most amazing interviews that I've ever done. He had, things to say about JWST, its current status. It's going to last for 25 years. Was a piece of news, at least, maybe more, and a bunch of other, how they're dealing with the micrometeorite impact and what the plan is in the future on how they're actually going to change the way JWST is going to make its observations. And then he talks about what comes after with LUVOIR, and then what comes after LUVOIR with on orbital constructed telescopes and servicing, and then after that, and it's just at this certain point my mind is just overheating and just completely blown. So you will absolutely love this interview if you are interested in JWST. All right. Thank you, everyone, for watching us today on both YouTube and on Twitch. Thank you to all of the moderators for helping out. Thanks to Nancy Graziano for organizing everything behind the scenes. I know tonight's episode was a little stressful for her, so everything is going to be fine, Nancy. And thanks to Pamela for engineering behind the scenes. You didn't hear her, but she was here in our hearts all along. All right, so on to the interview. And for the rest of us, thank you, and we will see you all next week.
Hey everyone, welcome to the weekly Space Hangout special interview. Today we have with us Andy Saunders, and he's put together an incredible book called Apollo Remastered. Happen to have a copy of it here. It is an incredible book. Andy, welcome to the show.
Thank you very much for having me on, Nancy.
Yeah. So tell us about kind of your background and how you started doing digital photography remastering or analog photography remastering.
Well, I've always had an interest in photography. It's not my professional background. I was a kind of a semi-professional photographer for a while, but my background's in something entirely different. But on a personal level, I've just always had this obsession with the Apollo moon landings. Since a child, as long as I can remember, utterly obsessed with it. But I'd always been frustrated that something very important was missing, and that was an image of Neil Armstrong on the moon. I wanted to see him on the moon, this absolutely pivotal moment in human history. I wanted to see it, but I couldn't, and we've never been able to because he held the camera. So the photographs that we see are of Buzz Aldrin. That just always really, really frustrated me. And as I got older and more knowledge of digital photography and digital processing, a lot of the viewers of this show, I'm sure, are aware of image stacking that's used in astrophotography.
Right.
And I just thought, if we can put Planet Mars through this, why can't we put Neil Armstrong? So that's when I looked at the other source of film that was shot on the Apollo missions, that was shot by the small format 16mm movie camera. We call it's like a cinefilm camera for those that aren't aware, that type of camera. And I applied this stacking technique to Armstrong and managed to reveal this incredible amount of detail, this clear image of him, finally, this image that I've always felt was missing from the history books. And that really got the momentum for me to then start and look at the whole back catalogue of imagery from the Apollo missions.
Yeah, I remember when you released that image, you could actually see Neil Armstrong's face on the surface. And was that one taken from one of the movie cameras?
Yeah, so that was the 16mm DAC camera. So it was locked off in the window of the lunar module, filming the EVA at quite a low frame rate. So in the past, we've had SD versions of this. And if you lift one frame, there was clearly a moment where he lifted his gold visor and there was a glint of something, perhaps face coloured. But it could have been, Dave from down the road. It was just a face. But then when we had HD transfers of that film, and then applying this stacking technique where we separate out the separate frames, put multiple frames on top of each other, and you can pull out much more detail, that's when not only is it a face, that's recognizably Neil Armstrong. I could see his eyelid. I could see, it was almost like I was an archaeologist brushing the dust off this long forgotten artifact, or like I'd gone back in that moment to 1969, and I was in the lunar module looking out that window with Aldrin, watching this incredible moment in history unfold before my eyes. And that's when, in fact, it was in this office, it was about 10 years ago I did that image, late at night, everyone had gone to bed. That's when I do a lot of my editing. And I mean, my heart was pounding, as I was processing this, because I knew what it meant. And it just hit me. No one's ever seen this moment other than Alden in this clarity, and I need to share them. I need people to see them. And so I just started to post images on social media. And that's when the idea then came to actually eventually do a book.
All right. Yeah. So now, if I understand correctly, all of the original film and from the Apollo program, and actually even the Gemini and earlier in Mercury missions, have been kept in a vault, frozen, and to preserve them as best as possible. How were you able to convince NASA to let you have access to this incredible treasure?
Well, luckily I didn't need to ask. I mean, there's no way anyone would let me anywhere near that freezer. I mean, that film is so delicate. It's very thin-based film that they developed so they can fit more photographs on a magazine. Obviously, you're concerned about weight and volume to take to the moon. So it was very, very delicate, thin-based, obviously incredibly important, valuable film. And that's why it went into a freezer. So when they first got back from the moon, they made duplicate copies. Those originals went into the freezer, and then everything then was based on the duplicates, or copies of duplicates, or copies of copies. And that's part of the reason for the degradation of quality in everything we see and everything we have seen. That was another frustration, is some of these iconic images, including on NASA's website, for example. I just saw them and I thought, they're great in the content because they're inherently amazing, but technically they weren't very good. And that didn't make any sense because they use the best cameras, the best film, the best photo lab. We should be seeing them in a better state. And this is part of the reason. But NASA got that film finally out of the freezer, along with a project with Arizona State University, and scanned them all to this incredibly high resolution. But they're just raw files. They're effectively like a digital photograph of a piece of film. So you can call it, it's not actually a negative, the color film, but we can call it a negative. This is the actual film that was in the camera. So it's effectively a digital photograph of that. So because it's analog film, you need to then digitally process those raw files to present them correctly. And that work just wasn't being done. They sit on a server, and thankfully, thanks to NASA's open source policy, anyone with the enthusiasm, the time, the skill to go and work on this footage can just go and do it. Nobody else was doing it. So I made it a mission, and 10,000 hours later, here we are.
Yeah. Wow. So how many pictures did you actually work with?
Oh, so they took 35,000. I went through every one because once I started this project, I thought there's no point doing a project like this and half doing it. What if I got to the end and I missed something? So once I committed to doing it, I just went through every single one, took it mission by mission. There was about 10 hours of DAC footage, so this 16 millimeter movie footage. I went through that frame by frame to look for scenes that would be appropriate for this stacking technique. So that was the objective, just to assess everything that landed on a piece of film during every Apollo crewed mission from 7 to 17. I would assess, and I've processed and digitally processed the best of those. And there's about 400 in the book, but I worked on thousands. Yeah.
Wow. Yeah.
And making that selection was as difficult as you would imagine.
Yeah, I was just going to say, how hard was it to choose just 400 pictures? Was that kind of a limit set by your publisher, or was that a personal limit?
I mean, you just tried to lift the book up there, Nancy, and I could see you grimace because
yes,
it's already.
This thing is heavy.
Yeah,
and it's big and it's gorgeous, but yes, it's heavy.
So that there was almost that physical constraint of what size of book can you physically read, because I wanted it to be that large format as well. Mm-hmm. So we kind of settled on about 400 is the maximum we can get in. I'd like to have put 2,000, but I couldn't. So making that, I mean, there's never been this many before. I mean, there was a book called Full Moon in the 90s. I think that had about 125 or so. So 400 is an unusually high amount, but still, of course, thousands are effectively missing. But what I wanted to do is, it's not just a book of these, oh, look how bad this image was and look at how good it is now. The idea is it's the ultimate photographic record of the whole of Apollo. So it has to have all the classics in it as well, the iconic images, Earthrise, Blue Marble, Man on the Moon, every photograph that we see often, but not necessarily in a very good state. We can now see those as more clearly than we've ever been able to, as well as those kind of, well, this is some new detail we've never seen. This is something new we could potentially learn. So picking images that have a historical significance, picking images that, there are some that just instantly translate the awe-inspiring nature of human space exploration. So they just, as you go through them, they just hit you and go, wow, look at that. And they're in. So there's panoramic shots, so I've stitched where these panoramic sequences, I've stitched those together. And there's like 3-page fold out, so they're great at, portraying this, the grandeur and the scale of the lunar environment. Those have historical significance, but the key thing I want to do that's not really been done enough is to show the human side to the missions. So when we often do see spacemen in these photographs, but it's an anonymous white spacesuit and a gold visor. Mm-hmm. If you can see through the visor, or if you can see through a window, or if you can step on board the spacecraft and actually see these people, you can just connect with them more and what they're doing. So with this 16 millimeter film in particular, that was great filming inside the spacecraft, I want the reader now to feel like they can almost step on board that spacecraft and look around, go along with these space explorers on the most incredible ever human expeditions. I've always wanted to look out the windows they look out of to see what they saw. And I want to see how they saw it. What would it be like if I went? So I want this to be almost as close as people feel they can get to stepping on the moon themselves. So all those criteria, plus researching every image to work out the chronology, so that actually we've got pertinent quotes from the astronauts at the moment they took the photographs. What can we see in the image? And because they're in order, we can follow each mission, and we can follow the whole progression from seeing the first views of the curvature of Earth through to walking on the moon to the last steps on the moon. So being able to tell the story through the images was also another factor.
Yeah, and you do that really well. It's incredibly well put together. And you talked about the human side, and the image that you chose for the cover of the book is absolutely stunning. It's Jim McDivitt on Apollo 9. And could you talk about that image a little bit? It's just that image just, I mean, it just.
Nancy? Oh, yeah. Has she stopped for you? Have you got me, Fraser? Shall I carry on? Sorry. Yeah, so that particular image, I mean, when I'm looking through these 35,000 images, they're very dark, they're very underexposed, not necessarily the original photograph, although in this case it was, but also the scan is quite underexposed. So that frame is almost entirely black, except for the little window, which is the little hint of something that made me think, actually, there might be something interesting in this one. I could see the little purple square, which is the COAS guidance site that they used. So I enhanced that one. And when I just did a basic enhancement, I could clearly see, wow, that's Commander Jim McDivitt. And, I could see it was going to be an incredible portrait. He's almost like he's looking up in wonder. And we've got this great atmospheric, cinematic shot almost of Jim McDivitt doing his work in 1969. And although it looks like that's what he's doing, like he's looking up in wonder, the reality is even better. Because in researching this, and I spoke to Rusty Swikart, who took the photograph, in this moment, Jim's actually undertaking the first ever docking in space between two crewed spacecraft. We see every day, all the time, in recent times, where the astronaut will come through the tunnel and they shake hands. This is the first time that ever happened. And actually the stakes were very high, because this was also the first time that we had people in a spacecraft that was incapable of getting them home, because they were in the lunar module, which they were testing in Earth orbit. So it had no heat shield. The heat shield was on the command module, which is they were trying to dock to. So if they didn't make that docking, and this was the first time it was ever done, they were in, big trouble. So the stakes were very high pressure moment, and he's actually undertaking the docking in that moment. And yet it's this great cinematic atmospheric shot. So that was a bit of a no-brainer for the front cover for me.
So Nancy's internet has cut off. Have I got my audio? Yeah, okay, all right. Yeah, so Nancy's internet cut off, which was too bad, because Nancy's the one who's read the book, and so she was doing the interview. I haven't had a chance to read the book, but I, of course, Nancy predicted that I would be forming questions in the back of my mind while I was watching this interview. What about the scientific value of these pictures? I mean, if you are taking stuff that you're taking images of the moon that were just really rough, and now you can almost pull out like geologic details, I'm guessing, out of some of this. Have the scientists, geologists and stuff, had any interest in what you've been working on?
Not specifically. I mean, they also had photographs that were of even higher resolution that were taken from the sim bay of the service module. So they had the panoramic camera and the metric mapping camera. So there are a few of those images in the book, but they're not quite as interesting as those taken by humans, if you like, directly. So there aren't that many in the book, but they're of an incredibly high resolution. And in fact, in some of those from lunar orbit, with a little bit of digital enhancement, you can actually pick out the lunar module on the lunar surface. So I think it's in those photographs where, from a geologic point of view and a scientific point of view, you could potentially pull out more detail. But like I say, I didn't work on as many of those as I did kind of the Hasselblad shots.
Yes, I'm back.
Oh, hello, Nancy.
So what did I miss?
I couldn't really answer the question about the scientific.
Okay. Yeah. Okay. Well, I did want to ask about, could you talk a little bit about the equipment that the astronauts had, the cameras? I mean, we talk about that the images are kind of low quality now, but they had some actually kind of state-of-the-art equipment for the time, correct?
Yeah, I mean, even for today, I mean, the cameras are absolutely incredible. It's more how we see the output of those images and those cameras today that up until now has made them not look as great. But actually, you know, a photograph from a Hasselblad, like, I don't know if you can see here. So this is an original Hasselblad 500 EL. So this is the camera that they use, a commercial camera that they developed into this one, which they took onto the lunar surface, the Hasselblad HDC. So they had to make quite a lot of adaptations to it to make it space worthy. But they were incredible medium format cameras, incredible film. They used the best lenses, Carl Zeiss lenses. And they were developed over many years until they actually, you know, took this one till Armstrong and Aldrin took this one onto the lunar surface on Apollo 11. And through the book, you might notice it feels like the images get a little bit better. And I've been asked before, is that because did the technology get better through the missions? And they didn't really. There was some very minor adjustments, but I think that improvement is more the photographs were critiqued when the astronauts got back. So the next mission, you know, they were learning all the time how to take better photographs. They were all great. You know, there was no automated feature on this camera. There was no viewfinder. So they're literally pointing the camera and setting the focus and the aperture themselves when they're already, of course, very busy on these missions and on the moon. And yet the vast majority of photographs are really well exposed, really well framed. But as the missions got on, I think they did get perhaps a little bit better at the processing as well. And they took more. So on Apollo 11, as I say, they took one camera and one film magazine onto the lunar surface, which is just, you know, 200 photographs. You imagine when we go back to the moon with Artemis, we're certainly not going to miss taking a photograph of the first woman on the moon. We'll have thousands from every angle, and we didn't get any. And part of the reason is they took one camera. But on Apollo 17, they took multiple cameras, lots and lots of magazines. They took just under 4,000, I think it was, Hasselblad handheld photographs on that mission. So as you take more photographs, of course, there's a high proportion that are great images, which is why it may seem that the photography got better throughout the missions.
Yeah, right. So the book is Apollo Remastered, and it's absolutely stunning collection of images. And Andy, you've done an incredible job. The book comes out in the U.S. At the time of this airing. It will be out correct?
October the 25th. Yeah.
Okay. All right. So it's available wherever books are sold, I'm imagining.
Yeah.
Yep. Yeah. So tell us where we can always find you online, or do you have a website and social media?
Yeah. Well, I started really doing a lot more sharing of my photographs on social media, which I continue to do, mostly on Twitter at Andy Saunders _1. The same at Andy Saunders _1 on Instagram. There's a Facebook page, Apollo Remastered, and the website is apolloremastered.com. There's lots of information on there about the background, the project, the cameras, and the book, of course.
Okay, great. Well, thanks so much for being with us, Andy. It's been wonderful to talk with you.
Thanks for having me.